Good evening, everyone. Welcome to Azure Sketches episode 3. And today we're going to be focusing on a very relevant topic, and that is regarding best practices in securing web apps. Now, up to this point, we've been focusing quite heavily on locking down the landing zone and assuming your workloads are virtual machines, which they might still be virtual machines. And but we've covered some fundamental and important concepts regarding the landing zone. And the landing zone is a prerequisite for any cloud adoption. That includes the firewalls, the virtual network gateways, routing to on-premise, how you segment your applications, whether they're cloud native or not. So today, we are going to be focusing on or making the assumption that your applications, you've got the landing zone in place, and now you're deploying cloud native applications. And how do you secure these? Ideally, when you deploy these, your web apps, your web applications in the cloud, ideally you don't want infrastructure. You want them to be, you want to really be focusing on your code. So you want to be deploying it to services that have a very minimalistic footprint, whether they're containers or whether they're web app for containers or even web apps that run your code base, Windows or Linux. So what we're going to do today is we're going to do it a little bit differently. And I'm hoping that this kind of format and the number of presenters, for future sessions, we will cover different aspects using multiple presenters. And I think, I'm a specialist in a particular area. Then we have Gordon, and we have Pavendran, and we have Ronald, and we have Nils, who specialize in their own areas. So we want to try to ensure that we bring the best of that expertise to the forefront. And so what we're going to do today is look at the entire pipeline of your application. Your application more than likely has your code, the infrastructure the code runs on, and your database. And there might be other pieces in there, like application pieces. But for the sake of today, let's just focus on that core pipeline. And our goal for today, a scenario for today, is we've been tasked to build and lock down a cloud native application across your entire pipeline, and also focusing on the life cycle of your application. Life cycle meaning that during the life of your application and during the many code changes that your application might go through, you want to ensure that is secure all the time. So it will involve culture. It will involve the way people work. It will involve what identity people use. It goes down into process, people, process, and technology. So we're going to break up today's session into 15 to 20 minute slots covering 3 areas. First section that I'm going to focus on is the platform. So I'm going to spend about 17 minutes on doing some sketches, just to give you some visual context around what makes up the platform. When I say platform, what do I mean? Is it the entire Azure platform, or is it the infrastructure to run your app services? Pavendran is going to focus on securing the code, and he will delve into the Azure DevOps side, which is a very powerful component to wrap your people, process, and technology elements. And then Ronald's going to focus on more, the state of your data, because that's where your asset is. That's where the gold of today lies. How do you secure your database, and what capabilities that you have to do that? Today's session is going to be about how do we secure these things for a typical customer once they onboard the application in the cloud. And Azure's got a lot of features and a lot of capabilities, for us to do that. So the platform essentially is all of the infrastructure components and services to host your application, whether they're stateful or stateless. So whether it's the logical server for your PaaS database, or whether it's the app services infrastructure to host your code, or whether it's the app gateway and the Azure front door, and Azure DevOps to manage the lifecycle, whether there could be a combination of IaaS, PaaS, and SaaS. Okay, so today we're going to use Microsoft Whiteboard. And I'm going to fly through this, but it should set the context of the discussions that Ronald and Pavendran are going to have, and you should walk away with a visual representation of how these pieces fit together. So, what makes up the platform for your application? So what we have is we have the stateful tier. Now, the stateful tier is made up of your databases, right? So you got a combination of databases, and Ronald will cover this in more detail, but I want to represent these. All right. In Azure, this is called a Azure SQL, right? And Azure has got multiple relational databases, and so do they have NoSQL databases. But for today's exercise, we're going to go for Azure SQL. So this is the PaaS offering. And your databases are stored in something called a, you have to spin up a logical server. A logical server is not a physical, it's a logical representation of the container that hosts your SQL databases. Because when you specify your connection strings, you need to have the FQDN, the server name, and your database. All right. So that is something Ronald's going to cover. What I'm going to focus on now is the platform that makes up the PaaS layer. Now, we're not doing virtual machines today. What we have in this square block is a service called App Services. Right? There's quite a few app services that Azure has. Logic App, Function Apps. It can run apps inside an ASC. Web app for containers. Linux web apps. Windows web apps. So that infrastructure is called App Services. And when you are spinning up, when you want to commission an app service, you need to specify something called an app service plan. So your app services is not the billing unit. Your app services sits inside a container. Just like the logical server here, your app services sits inside a container. Does anyone know what this container is called? Let's make it interactive. This is an app service plan. Right. Right. Can you spin up an app service today without an app service plan? Someone says no. Care to mention? Care to comment?
I think he answered no from the other question, Lawrence. What's the container?
Right.
No, I think he answered no from the other question.
Oh, okay. Right. So you need to have an app service plan, right? Now here's the service that you can spin up when you spin up app services. Let's do that so that everyone's on the same page. You have web apps, Windows, web apps, Linux. You have web app for containers. Web app for containers. And this is what we're going to be focusing on today. You also have function apps. Function apps. You've got logic apps. Function apps, logic apps. Am I missing anything? Okay. So if you want to spin up one of these services, you need to have some sort of consumption plan. Now, the app service plan defines the billing boundary. So the where your code sits, your code does not sit inside the app service plan, but your code actually sits inside an app service in the app service plan, right? So this is your app service. Now, when you spin up an app service plan, or when you choose an app service plan, you have SKUs. You have a premium SKU, you have a standard SKU, you have basic, you have shared tier. These SKUs determine the capabilities of this app service plan, right? What capabilities can it support? In terms of the number of instances. Now, you have an app service plan, which is the overarching container, the billing container, not necessarily the functional container, but the billing container. Then you have your individual app service. Now, here's the thing with an app service plan from a consumption perspective. Best practice is that an app service plan can potentially come with 10 or 20 instances, right? So inside an app service plan, you have multiple instances. And all that instance is, right? That instance is really if you go for the premium SKU, for example, it really is in the backend a virtual machine. That's what an instance is. So with that in mind, if you've got an app service plan that can scale to 10 instances, an app service plan then logically can support multiple app services. So you don't want to be, I know customers make the mistake of spinning up an app service with a dedicated app service plan. And that can start ending up being a very costly exercise, right? So if you had to use your app service plan in a very efficient way from a cost perspective, what you want to do is really run multiple apps on your app service plan. So this is app 1, that is app 2, and that is app 3. Right? And remember what I said, these are instances, right? That's an instance. So you could potentially have multiple applications make best use of the consumption that you have. But the moment you start increasing the number of instances, you're going to pay for those instances, right? So just be very cautious of that. This is also a scale unit, which means that you could auto scale the app service plan, and you could also do per app scaling. So you could have a scenario where you could have app 1 maybe use 3 instances like this, and you may have app 2 use 4 instances, and you have app 3 use, and then you have app 3 maybe use 2 instances. So you can do that. There are limitations to this. Okay, just at a very high level, I don't have much time, but the app services is the main thing from a security perspective. Today's session is about security, right? This is what we really want to be protecting. This is where your code is sitting. That's where your code is, right? It's deployed in infrastructure in the back end, and Microsoft's managing it, but ultimately that's where your code is sitting. So there's a couple of things that you can do very, very quickly, right? There's a couple of things that you can do to your to lock down the app service. Let's just get rid of this. Right. So each app service comes with an IP address, right? So each application that you go there is a domain name. Each of these is a domain name. Each of these is a domain name. But did you know that the app service plan IP address is exactly the same? Because it's an app service plan, the IP address is tied to this app service plan. If you go look at the IP address of app 1, app 2, app 3 in this app service plan, it's exactly the same. It's identical. So how then do you point a domain coming through? It's going to look at your header that you're coming through. So what you want to do from a security perspective is ensure that in the very least, traffic coming into this application is using HTTPS. Now, from a testing perspective, you could get away with HTTP, but from a production perspective, there's a tick on each app service that says, okay, I want to lock down this app service to allow HTTPS, which means that now all communication to this environment is encrypted. And ideally, what you want to do is enable TLS version 1.2, transport layer security. So it used to be called SSL. For that, you'd need to have a certificate that matches the domain name that you want to request on your app service. And you need to have the tick turned off to only allow HTTPS. And this is an application specific setting. This is your starting point in terms of enabling security. To enable TLS 1.2 or 1.0, you need to have a certificate for the domain name that you want. You have multiple options for certificate. You can import your own. You can fetch fetch a certificate with the thumbprint inside a key vault. You can also use an app managed certificate. And there's also a free certificate that you can use, the import certificate and the purchasing the app service certificate from Azure. You can export it, but the free app managed certificate, you can't lock down naked domains, which is anything other than like a www, but it's very convenient when you want to lock down a service and you don't want to be messing around with certificates. You can bind the certificates in a couple of ways.
So, Lawrence, to add on that, you can also get the Let's Encrypt extension. So they'll do the cert renew and stuff for you for your app service.
That's right.
Which is another option. And then before we go too far from it, like you mentioned, the IP address is a small gotcha. And I don't know if Michael or Ronald will cover it just now, but when you do, like if you, for some reason, have your SQL server exposed across the internet and you want to do whitelisting of IP addresses, the app service plan has 5 IP addresses that it cycles through. So you might go there and see, hey, this is the IP address that it is now, but it will cycle through 5 of those outbound IP addresses. So you just need to make sure you add the full list. There's like a second field that shows you this is the full set of IP addresses that those could have on outbound traffic.
Yes. And there's a I don't know if many of you know what mutual TLS is. So mutual TLS is the standard TLS. Only one side needs to have a certificate, right? The server side certificate. With mutual TLS, you can turn it on an app service where the client will also need to have a certificate to verify his identity. Now, this kind of requirement is extremely secure in like financial services. So that capability is there. It's like an unsung feature of the app service, but it is there. The next thing that you want to do before I hand off to Pavendran is these app services, right? You don't really need to, there's some work you need to do, but you don't really need to now handle authentication and authorization inside your code. I mean, these are features of the scaffolding, right? These are features of the app service. It's not a feature of the app service plan. It's a feature of the app service where you can say, okay, I want to federate with Azure AD. I want to federate Azure AD. I want to federate with Facebook. I want to federate with, and normally these are like OAuth or SAML federation. I want to federate with Google. And this is one of the main reasons, and this is a really important security principle to adopt, that when you block traffic to an application, right? That's only one half of your job done. The next thing you want to do is to validate who the individual is who is authenticating. The benefit of not managing security on your own is that if you federate with Azure AD, for example, and someone's authenticating here, all the app is going to do is not authenticate it itself. It's going to pass that to the IDP or Azure AD, and Azure AD is then going to there's a relationship between the app service, and you would have registered your app with an enterprise app on Azure AD. If you have additional policies like conditional policies, or the device that you're coming from, your device is not secure, or the country you're coming from, you'd now benefit from having security capability with Azure AD. So authorization, and it's not just used for authentication, right? I mean, you can configure it to validate using scopes what the person is allowed to do, and that exchange of scopes is handled at the authentication phase in terms of what access or what resources does the individual need to access. That's all part of cloud native authentication. Another thing important is if you want this app service to talk to other resources, the very important element you don't want to be, and I'm sure Pavendran will cover it, and I'll lead it into Pavendran's talk now, is you don't want to be storing your code and your secrets. Let's just go for a color I haven't used. You don't want to be storing your code and your secrets inside your application, or your connection strings inside your applications. You want them to be stored. You want them to be stored encrypted somewhere, and you are using variables to call those secrets, because you must assume at some point someone's going to get into your code, right? You must design for failure, or you must design for that inevitability. All you can do is to react and to automatically mitigate. If you're deploying an app service, you must deploy an Azure Key Vault. Your secrets, your certificate, your username and passwords, all of that information is stored in an encrypted vault. You have the opportunity to use Microsoft platform keys, or even use your own custom keys, and I see certain customers actually using that. So I'm going to leave it at that. I just want to repeat and emphasize. I don't want to cover too much today. Number one, ensure that you are deploying your app services inside an appropriate app service plan, and ensure that that app service plan has enough resources to cater for your apps that you're going to be running. What you want to then do is ensure that each app service is locked down by a certificate, and you are disabling HTTP traffic, and you're enabling TLS 1.2, and you have custom domains for the relevant services that you want to. Point number 3 to remember: do not take the effort of doing authorization authentication inside your app. Offload that to a service that does it for you, like an Azure AD, and it's the same method that the way Office 365 actually works. Office 365 itself doesn't do authentication. It relies on Azure AD identity. So as we move on through the coming weeks, I will continue elaborating on other key security features that we can turn on in terms of the platform. So today I'm going to be focusing on the platform. With that, I'll hand over to Pavendran, who will take us through how we secure the code and getting into some Azure DevOps.
Yo, check it, you set up like a Twitch person, huh?
Yeah. I've got a surprise for tomorrow's meetup. I've taken it to another level. I'm not going to use that trick in this one. Okay, so yeah, like Lauren said, I'm Pavendran Naik, and I'm an MVP in the dev tech realm. So primarily do .NET Core stuff, but I sometimes play with like cognitive services and ML Studio to make myself believe that I understand what I'm doing in data science stuff. It's sometimes fun. And yeah, so sort of today, a lot of key points Lawrence highlighted is I'll be going through some of the fundamentals of securing your code and some nice, easy add-ons or bolt-ons that you can get pretty much for free nowadays, considering that Microsoft supplied quite a few of these companies. So this is my GitHub profile. All my contact information is here if you have any questions later on. And for this demo, what I've done is I've set up this little repo here. And there's a lot of things that I'll come back to in a bit. as we progress through the sample, you'll see already there's a couple issues. There's quite a few pull requests. And when we go into the insights piece, you'll see some other bits of information there. Let me run you through what this application is first. So I get to do cool things like point up there and say, oh, look at my solution explorer. It's just above me. This is pretty much just like a stock standard Blazor server application. And what that is, so it's all server rendered code, and it's streamed to a client in the browser using SQL. And it's just the template. And I've only gone ahead and made one modification, because Lawrence alluded to it in the beginning, that I wanted to demo key management. And again, I'm going to do sort of the fundamentals of key management. In a ASP.NET or even a Blazor application, you have this app settings JSON file here. And this is great for local development. So you just need some test values in here. You put it in there, you run it. These are the values that get served in your app when you run it locally. But that does not work or isn't secure, because this is pretty much, it's just JSON, it's plain text. You don't want to commit production values in here, because there are people monitoring public GitHub repos, searching for keys. And also you can just go into GitHub and search for like popular keys. Like I remember back in the day, I've tested it. You could just search, I can't remember what it was, but Foursquare, their key was called a specific thing. And it just went up to GitHub and you searched it and you saw everyone who committed their Foursquare API keys there. So you don't want to be pushing this file with production values. I've added two values here. I've got one called app settings value and I've got GitHub secret. And then what I'm doing is in this template, in the service here, I've added these two lines where I'm querying the keys using the configuration manager. And then I'm just using string interpolation and output the two keys. I was lazy and I didn't want to make too many code changes, so I just sort of hacked this with a forecast endpoint. And let's go back here. So you see, I've just got these values of local app settings, local app settings. So when I run this, hopefully it opens in the right browser. Here in a second. Slower than usual. You'll see this is pretty just stock standard Blazor server app. We've got the famous counter, the get counts, amazing functionality. And then there's this fetch data endpoint. We're ignoring all of this. The full stuff is now app setting stuff. So this is pulled from a config and outputted there. Okay. So I've got this app, I've built it locally. I'm making the assumption that you're using some sort of source control management. We demoing this with Git and GitHub for this. So now I've got this code here. It's on the GitHub servers. What happens next? Like I want to deploy this. And sort of the first step is getting this set up. So GitHub Actions, it's pretty much you set up a workflow and you can get this deployed out to whatever cloud provider. I'm using Azure for this. And oh, actually, I'm in the wrong place. Let me show you what this file actually looks like first. I'm not going to go into details of this because this is not really main piece, but you'd want to have at least some form of continuous delivery. And at some point you can build on top of this with continuous integration, because the days of copying and pasting stuff or FTP and stuff on a server is not a reality. It's a very easily be like, do you necessarily trust the process of somebody copying something and pasting it? So like I could have written some code, committed it, and hoped that gets deployed to a server. I don't know what happens in between. Somebody could go in once they have that zip folder, modify the code, and then deploy, in quotation marks, a modified version. So it's not a very traceable process, copying and pasting. Also compliance, like there's no regulatory body that will approve bin dumps nowadays. You will get fines for that. So this workflow is pretty simple. Check out the code. I'm just working off the master branch for now. The interesting piece to look here is the main piece that I've added is now on the GitHub side, I'm doing variable substitution. And in the demo, I'll show you two pieces. I'll do one set of variable substitution in my build process, and then I'll also do some substitution in Azure using the app settings for my app service. This as well, it's using a pre-built step from Microsoft. I tell it which file I want to do the substitution. So this is my app settings of JSON and the variable that I'm going to substitute. So I'm substituting GitHub secret with the secret value here. And when we get out of this, I'll show you where that's set up in GitHub. Then all of this is pretty stock standard .NET Core stuff. I set up the SDK, do a build, I publish, and then I deploy it to Azure here. You'll see here again, I've got another GitHub secret here for my published profile. Now, while we're speaking about those secrets, I'll show you where that's set up. So if I go into settings here, and you'll see down here, there's secrets. This is where I've set up those two secrets. And so GitHub has user management, and you'll see here anyone with collaborative access can view these secrets. This works, but I don't think it's robust enough in terms of its role management that this will work for large enterprises where they can manage secrets from GitHub. But it does work, and it's a better solution than shipping production values in your repo. So these are pretty easy to set up. You click new, you give it a value, you give it a name, you give it a value. And I've already gone ahead and set my published profile and a value here. And what we'll do is later on at the end, when I'm showing you the actual running app from Azure, for anyone that doesn't believe me, I'll go in and update these values to whatever someone in the chat chooses. Cool. So now if I switch over to Azure, we'll see here what Lawrence mentioned. I've got an app service plan. Let's see a little penguin there. So that means that this is the Linux app service plan. And I've got an app service in there, and this is all hosted in South Africa. And what I'll do is to demonstrate again the point of what Lawrence was saying, where an app service plan is a container for all your app services. Is I'll navigate from here, going inwards. So my app service, I've currently got it hosted as a P1 version 2. That's overkill for the app that I have. And there's a few ways to navigate this. You can click here or there to view all the app services in your app service plan. And there's my one here. This is already running. And I browse it now. You see it's the same app, but this is now in Azure. When I go to fetch data, we'll see these values are different. So these are the actual values that I've configured. So this is hi from GitHub. That's the value I set in the GitHub secrets. And then I got hi from Azure, which is the one I've set in app settings. Now, Gordon's picking in my name. I have to be very descriptive. I don't want to take Azure Transform.
The sec in DevOps is killing me. Everyone trying to make other ops a thing.
Yeah. So Some of the stuff I'm going to talk about also falls into this newer concept or a buzzword that's on the rise. It's DevSecOps. And I'm not sure how people feel about that. It's developer security operations. I feel as if it's just another
That's
buzzword.
that name I was talking about.
Okay. Yeah, so I wouldn't mention DevSecOps too often. I don't want to offend anyone. Now, seeing that I've got you already unmuted, Gordon, just so people believe me that I'm not hardcore and stuff, give me a number, just a random number, 4-digit number. Actually, you can make it 3-digit number in case you give me your like card pin or something.
I was going to say 42 as a number, but then you'd
No,
know
I'll do
that.
that.
So then 9. And then 9, I don't know. Just because you would have guessed 42.
Oh, okay. So I'm good. So what I'm doing here now is this app is already deployed, right? I'm not changing anything in GitHub. I'm not changing my app setting the JSON locally and doing a push. I'm gonna hit OK and hit save. And now what Azure is doing, it's going in and doing changing the value for this environment variable wherever this is hosted. And this one's pretty impressive because it takes a couple of seconds. So you see it refreshed, it went away, and there we go. My config value changed to 429. And that's pretty much, that's the fundamentals of key management. There's many, many ways to do this. Usually what I see is as the landscape gets more and more complicated, you've got multiple products and like systems talking across each other. A lot of large enterprises opt for centralized config. So they'll use something like Key Vault is a great example. HashiCorp Vault is another one that's pretty popular. So there are a lot of ways to do it, but as sort of an intro and just getting into key management, these are 2 pretty good options. And I prefer doing it in Azure because I kind of prefer, even though their role-based access control is a lot more complex, I prefer that granularity that they offer us. And then, like we mentioned before, things like connection strings and so on can go in here. So that's the app setting stuff done. And that covers most of the massive code changes that I've made here. Now, on the GitHub side, I'm relatively new to GitHub. I've had an account for a while, but I've been tinkering a lot more, contributing to some projects, and I hosted most of my personal projects on here. So I've got around to playing around with some of the security stuff, just sort of making my life easier. And GitHub, GitHub recently acquired a company that built a bot called Dependabot, and it pretty much saves you time because what it does is it monitors whatever package management tool you're using and your code. It does a diff. It is like, oh, okay, there's a new version. Maybe you should go to this, depending on the config that you supplied. And that config is saved in the YAML file here. And for my specific scenario, I've told it my package ecosystem is NuGet, where to look for my manifest or where the list of my dependencies are tracked for whatever type of solution you have. And daily, it just comes in here at 6 a.m. South African time, and it generates my dependency graph for me. And then it goes ahead against NuGet and it's like, oh, okay, there's new versions. And it does this amazing thing that probably save you a lot of times and great for this project is it goes ahead and creates merge requests for you. So I've intentionally, I don't need any of these packages, so I've just added them for demonstration purposes. I've added super old versions of some packages. So like a lot of these are from like 2013. So like EF4 2.1 preview 1. Don't know why I'd be using a preview version of EF Core, seeing that it's been released for a while. But Dependabot automatically found that it's gone ahead and told me that the latest version is 3.16. It's pulled the release notes for every version from the one I have to the current one, which this by itself is useful, having this in one space. So I can quickly go through and be like, oh, okay, this changed, that changed. Potentially there's no breaking changes. And then it's just a bit more information. And then it tells you the details of the commits going through those versions. And for some packages, it's not all of them. They've sort of done a validation process where they'll tell you the compatibility and it's sort of a gauge of risk for this. And for this specific package, it's unknown. I actually haven't checked. Let me quickly see. Maybe for XUnit and NewtonSoft, it's gonna, okay, so that's still unknown. Okay, so for all of these, it's unknown. I'm not sure which packages that they've done validation on. And it's pretty much all stuff here. And all I have to do is click merge and then do that. Give it a couple of seconds and that's done. I can delete the branch. And now that's in my code. It's updated NuGet for me. So I think that's pretty cool. Like I don't have to think about dependency management. Because GitHub acquired Dependabot pretty recently, what they actually in the middle of a migration where all of Dependabot's features will be natively integrated into GitHub. So if you go into dependency graph here, you'll see this will slowly build out over time with all the features. And this is that dependency graph I was talking about. It shows me the package I've installed and all its underlying dependencies as well. And then this project is not very useful, so no one's forked it, so no one's actually using it, so I don't have any dependence. And then this is the Dependabot. You see it's still in beta here. This is where you can go in and you can click this. It tells me which file it's monitoring, which is Messias project. And then you can click this if you want to manually run it after you've made some changes. The last piece I want to demo is sort of a security analysis tool for White Source Vault. And again, this was acquired by Microsoft this time and made mostly free. There is an enterprise version where you get slightly more features and I think a higher quota for using it with private repos. And this is actually a GitHub extension or application that you install. So if I go to my profile and I go to settings, and down here in applications, you can see I've installed this application White Source Vault for GitHub. And right now, I've only enabled it. It's a bit some information. And what they do is they actually monitor some of the industry's what I'd call them lists for security vulnerabilities. So a popular one is CVE that I know of, and then they also mentioned another one. So CVE and VD, they monitor these sites for any vulnerabilities in any versions, and then they look at your project, your dependency list, and tell you whether there's security vulnerabilities. I've just configured it for my 2 repos that I was testing, but I don't see any reason why you can't just turn it on for everything. I've got a few repos. Actually, let's just do it for the funsies now. So what this does now is I'm going to get something like 20 pull requests across my repos. Go back here. Is that it goes through all of my repos and it creates a pull request. Let's do this one. After a while, it should create a pull request here. Oh, there's no dependencies there actually. So actually, I'll just go to, oh, there's my phone buzzing, all the pull requests coming through. I can just do this. So let me search for the closed one, the one that it already created here. So when I was setting this up 2 days ago, when I told Waxel's Vault to look at this specific repo, it automatically goes in and does this initial configuration for you. The configuration is modifiable. There's documentation for it. And then it tells me all the stuff, gives me a little intro, and it adds one config file. So look at this. It adds this file, some scan settings, and then on what severity level. And this is a pretty cool one, I think, because this is the setting to determine what happens when it does detect a vulnerability, depending on the severity. And by default, it's set to failure. And what's really powerful about this is I went ahead and did some dodgy code, and I created a merge request. It took me a while to search for this, but I went searching through a few of these lists, vulnerability lists, and I found that jQuery.ui apparently in version 1.8.20, there was a cross-site scripting vulnerability that was reported. So obviously I decided to add that to my project, and I added it and opened a merge request, and immediately, like as I hit commit, it opened an issue. It's like, hey, like there's this medium severity vulnerability. It links you to the CVE site, with all the details. Actually, this isn't the full site. GitHub's got a cache version of this. The CVE site was horrible looking. I don't like going on it. It gives you a bit more details about this. And it tells you like this is a security vulnerability, and you have this issue opened here. But if you go in here and look at the actual pull request I created, it's failed the checks on my pull request based off the security report. So I was like, oh, I like this version more because that's a very good reason to change version or add a package in. And then when it ran and did its checks, it's like, okay, cool, this is not good. You can introduce this vulnerability into your project. Obviously, you can choose to ignore this. I can still go merge request, but if you add, depending on the checks you add in here, you can control the levels of this. And if I'm not mistaken, I think that is everything. I haven't been watching all their questions.
What you're saying is that you can use all these cool things to make it look like your repo is very active, even though it's just you saying it there. Awesome.
Correct.
I like it.
I was actually thinking about that, like these, especially these dependency ones, because what you could do is, like, I could squash this and rebase it, because I've seen this actually in a few open source projects, and I'm not sure how I feel about it. I can fork a repo, do a contribution, open a pull request, but when they merge it back in, it shows as one of the maintainers committed the code instead of I committed the code. And that's sort of an option. So like I could very easily make it look as if I committed this code instead of depend.bot. And then I get a nice continuous green graph here, making it seem as if I'm doing something every day. But in reality, depend.bot did the work. I just clicked a few things to make it look like I did the work.
I'm happy with that. Robots don't need any contribution love.
Yeah. So looking through, like Neil said, external mass configuration settings. One saying personal users key vault, Azure identities to get them. I'm going to use Azure app config for my sure. Yeah. It all depends on your situation. Though apps tend to do work for production stuff to an extent. If you've got like one product and you like relatively small team, or like where you can understand the complexity, you can keep the complexity in your head, it works. But once it gets to a point that you have to document it, you probably need a slightly more robust system.
The only reason I don't like that, even in, is like especially in small teams, is because that's where things would like, oh, it's broken, oh, it's fixed. How did that happen? I don't know. And the guys changed it. We're like saying with Key Vault, you've got that history that says, oh, this guy changed it.
Yeah.
I mean, I basically just don't trust anybody. So if I've got something that's going to give me an audit trail of things changing, I prefer that.
Oh, yeah, and Ronald hit the nail on the head. It's like, it works up to a point, but it does become a headache as the system grows.
Plus, we're running a lot of old tech, like .NET Framework 4.7, which I'm going to upgrade like end of this month. The startup times on your .NET Core app that you showed took like 3 seconds or so.
Yes, I know. I've made config changes to those projects, and they take a while.
Yeah, they take like 30 to 40 seconds to start up. So when you switch tabs and click refresh, you'll get a 500 error. Yeah. So yeah.
That's the benefit of using Linux. Don't use Windows to host your stuff.
Yeah.
Linux
it
is
was
fast.
shiny and new a few years ago.
Yeah.
Now we've got a lot of technical debt to handle.
I think that's it. I don't really have any tricks. Again, this is my profile. You can find me at those links. I think I'm pointing at the right thing. Yeah, that's me.
Proud contributed to the Arctic Code Vault.
Sorry?
Your badge on the side said proud contributor to the Arctic Code Vault.
Yeah, so we're deviating, but I wish that so they got all the contributions like from here, there, right? Which is all like crappy stuff. I only started doing some serious stuff on GitHub from here onwards, which is the stuff they don't have in the vault. So I'm a bit sad about that.
Well, I'm just sad on my profile. I mean, they list your biggest repos. So like I've got HBNet Core and other big projects there, but I don't have any of my little projects that don't add much to the world.
Cool. Then from our side, hi everyone. I'm Ronald Maria, also an MVP in Azure. So for today, I just want to speak a bit about data security and more specifically Azure SQL databases. So I'll just share my screen. So when it comes to securing data, I don't think explaining why that's important would be new to anyone, because your data is why your company survives, and having your customers' data exposed can cause financial harm, as well as it's the reason why most companies shut down today, because your databases are exposed, your customers' data is leaked, and it causes a bad reputation to the name of your company. And yeah. So for today, just maybe picture that you are an online retailer and you store a lot of your company's data and your customers' data as well. And it's an assortment of different data like phone numbers, addresses, credit cards, and all this data is critical to the health of your business. So for example, I have a database here called AdventureWorks, which is it's a sample database. So you have probably like tables and stuff. So before I get too into depth about the SQL side of it, when considering data as a whole and the security aspect, you always want to have a defense in-depth strategy where if you picture yourself as a malicious attacker and you want to gain access to data, what would be more difficult for you, having only one level of protection or many levels of protection? So having more levels of protection makes it more difficult for you to get access to something. And when it comes to databases, that's the approach that we want to take. And it's not specific to something that's on the cloud. It's also in the traditional sense of having your server on premise. It's the same approach that you'd take. The first layer on the outermost, if you want to call it like a blast radius, where on the outermost layer you have your network, and how do we secure that network to the database? So Lawrence mentioned the logical server behind Azure SQL database. So on the server level, we have the option to go to the firewalls and networks, and where we can block off all public access to the database. So no one over the public internet can access it. So that's one of the ways where on a network level you can protect your database. This is especially useful when you only want a certain virtual network to connect to your database. So you can block public access and also use something like Azure Private Link that takes your public servers and give it a private IP in your virtual network, where only the resources in that virtual network will have access to the specific server. The other way on the network level as well is only granting specific IP addresses access. You can add your own client IP as you want. Let's click save. So yeah, I tried a few different days. My IP keeps changing. Like now, it did change. When I switch off my internet and switch it back on, I'll get a new IP address. So every time I try to connect to it, it'll potentially have a connection issue that I'll need to manually add my IP. So not anyone that has access over the public internet will actually eventually have access to the data. By default, when you create a new Azure SQL database, it's all public access is blocked. It's allowed public access, but all IPs will be blocked. Then once we consider the network layer, then the next layer of protection would be securing your data in transit and at rest. So what that means is that when you query SQL, that data that you get back over the public internet, that needs to be secured. So even if a malicious attacker gets access when the data is in transit, is that encrypted? Will they be able to see the actual data or not? And the benefits of using Azure SQL database, a lot of the security now becomes the cloud partners' concern. In this case, it's Microsoft. And there are options for customer managed keys and service managed keys. But by default, transparent data encryption is enabled, which means that your data is protected in transit. You can choose to manage your own keys here as well using something like Key Vault. where you need to control the keys and also manage the rotation of those keys. Then the next thing is securing your data at rest. So what that means is that when your data is sitting in the server, how protected is it, and how do we manage it? So now looking at the database itself, if we just do a select on customers. So I have the same server connected on two different connections. One is a data user and one is a test user. The data user is an administrator, and the test user is someone that has non-administrator privileges. So at the moment, if I go to the VentureWorks DB on both the users, and do another select on customers. We see that both the users see the same data. All the email addresses are shown for the test user, and for the administrator, all the email addresses are shown. So from a security aspect, having email addresses exposed in your database is a security concern, and you need to handle that appropriately. So one of the ways that we can mask the data is it's on the database layer, and we can go to dynamic data masking. So what this does is that Azure SQL will analyze your database and suggest what fields should you encrypt. Not really encrypt, but mask them when running like select queries on them. And for example, we can find, let me just go back. So this is the customers table, and that's the email addresses. So on the customer table, the email addresses, we can add a mask to it. And we can choose what type of mask we want, whether it's a credit card, email address. So we can choose that. There's other custom prefix for things like phone numbers as well. So you can expose 0, add a padding for like XXX, and only show the last 4 digits of a phone number. But for this, we'll just use email addresses. And just click save. And this should be instant, where in my administrator connection, if I hit refresh, you can still see, an admin can still see it, but if the test user tries to do a select, they would see masked values.
Ronald, I missed there where you selected the role.
Oh, the role is actually 2 different users. So when I go file new connection, I connect with the test account.
But when you applied the masking in Azure?
Oh, by default, when you add masks, anyone that's not an administrator will have the masked values.
Okay.
Administrators can see everything.
Cool.
Yeah, but as well, you can also add other users that should be excluded from the mask. So if I have to put test here and click save, if I go back to SQL and refresh, I should see the email addresses again. So not only is my administrator allowed to see, but also the test user.
Okay, so I suppose that's where doing like principle of least privilege would actually be very important. because obviously your admins, you shouldn't always be able to see the PII data.
Yeah, and also the connection strings to your database, you shouldn't have your admin user account in your connection string to an application. You should give it like your app or something. So that was the quick overview of masking specific columns. So lastly, I want to just briefly touch on row level protection, where this is specifically useful in like healthcare scenarios where, for example, let's say you have a hospital and you have a lot of patient data and you want like doctors and nurses access to that patients, but you don't want all the doctors to have access to all the patients. You only want the doctors to have access to their patients. So for that, I have another database called healthcare.
Isn't that solved with the where clause on your query?
It does. It does solve the. Yeah. So I just have a few commands here that I'll probably explain while I run them. So creating 3 users, a manager. Okay, so this context is different from the healthcare system, but it's the same concept where you have a manager and you have sales representatives, and you have sales for the different sales reps, but you don't want 2 different sales reps to have access to each other's sales. So you want to segregate them based on who they are and what sales that person did. But you want the manager to have access to all sales. So row level protection is enabled at the schema level. So just creating a table for that, adding some values to the sales table. And if we do a select on that, we should get all the sales. So regardless of who the user is, if they do a select, they'll get all. So we're going to grant the select statement ability on all 3 of them. But here's where the security aspect comes into play. So for row level protection, you have to create a schema and a function definition for that. What this does is that if you are the manager or you are the sales rep that's requesting it, then only return the rows from the table. And we just apply that filter to the sales table with the state of on. And apply that predicate for the users. So if I'm the sales 1 representative and I query sales, I'll get all my sales, and the same for sales 2. And I only see the sales that I'm part of. But if I'm a manager, I'll see everything. And then we can also deactivate that sales filter. And then sales user 2 can see everything, and sales user 1 can see everything. And this is at the schema level, so it's not a performance benefit where you querying less data, but you're still querying the same amount, but before it gets returned to you, it sort of acts like a where clause, but it's more at the lower level. So yeah. So that's another way of protecting data where 2 different users shouldn't see each other's data. Then what else was there? Yeah, I think that was a brief overview of data and the different levels of protection. Is there any other questions? Also, one of the things Lawrence mentioned was TLS protection. So we covered transparent data encryption, but transport layer encryption. So by default, when you create Azure SQL database, you are protected from over the public internet. Traffic is encrypted, so that's transport layer encryption. Transport data encryption is for data at rest. And that's one of the corrections.
I actually have 3 questions, but please feel free to go before me, anyone else, because it might take a while.
I think Petrus asked one question here. I'm just checking now. Is the masking applied at page level? Could I use a subselect to pull the data that's masked? No. So the masking is applied at the database level. So when you query it, you use the user that you're trying to connect as, and that will be applied at the database level on Azure. Cool. Yeah. Yeah, questions now.
Okay. So I was curious, who owns the cost for the masking? So there must be some resource cost, especially if you're going to mask a column with like 10 million rows in some table. Do they mention who owns it, or do you just see a spike in like DTU usage or something?
I'm not sure. I haven't tried it with that extent of data.
So now the row level security and the masking and stuff is all part of the normal SQL engine. So it'll basically just be more CPU that's run as part of that execution.
So it's not a upfront cost like an index, it's per execution.
Yeah, so basically the portal, well, in that case, so Ronald was in Management Studio. It's just part of normal SQL functions that you can do. So it's the same like if you go and call a scalar function as part of your query, it's the normal overhead that you would get from something like that, just slightly more optimized.
And that leads perfectly into my second question is like, does the execution plan get modified? Which
I believe it.
Yeah,
I believe it does, but this and also like the page level thing would probably be a question for Niels, because he would know that better. I think like Ross said, I don't think it happens at the page level, but I could be wrong though.
If I ask Niels this question, he's not going to speak at the level that I understand. That's the problem.
I know, but that question is at the level that we don't fully get. So that's like the internals level, like where it gets to the, hey, if I order columns in a certain way, it optimizes my page storage better and that kind of stuff, which is very much, that's like what Niels does, just like casual.
Okay. My last question is, Ronald, why are you using Management Studio instead of Azure Data Studio? I mean,
so yeah, there's no reason for that. I never used Azure Data Studio yet.
Shame.
I'm just familiar. What I actually use is LinkPad.
Okay, LinkPad is pretty cool.
Yeah. So
there's more features than I use, but it's very
because I'm so used of .NET and writing link to SQL, then I don't have to remember any SQL commands.
So you're responsible for all the inefficient systems out there. the link to SQL.
Yeah. Cool. Yeah, I'm done.
Awesome. Well, if no one has, I mean, does anyone have any other questions? Otherwise, I think we can wrap it up. We are like 20 minutes over already. Cool. So there's no more questions. Thanks everyone for joining us. We'll put the recording of this up on YouTube and post the links on the GitHub repo as well. And yeah, thanks so much for joining us.
Yeah, thanks guys. Appreciate it. Thanks for giving us your time. Really appreciate it.
Thank you. All right.
Cheers, guys.
Thanks.
Cheers.
Yes.